What's the percentage of water in the concrete when it's poured?
We're probably looking at 15% water by volume. So your average mix is about 34, 35 gallons of water
Okay.
per yard.
And all that's got to evaporate when it dries, so.
Well, not all of it. Some of it's taken up in the concrete through a hydration process. When cement gets wet, it starts a chemical process called hydration, and it'll actually heat up. So like this load right here was 77 degrees. When it gets into hydration, it'll get up 120, 130, maybe even 140 degrees this time of year. In the summertime, it could get even hotter. I think, did everybody hear about the bridge that we're doing in Highway 78 up at the lake? I don't know if y'all heard about that. They've been working on it for years. They poured this concrete and it got so hot under the water it created thermal cracks in the concrete. And these cracks were so big you could stick your arm in them. That's how wide they were. So they had to go down there and remedy. I don't know exactly what they did, but that was created from heat because it got too hot. The larger structure you pour, the more heat builds up.
So when you have, say, shrinkage cracks, that's a lot of times from the water leaving the concrete?
Correct. You have about half of your waters in there for the hydration process that's needed for concrete to harden, and the other half is basically water for workability and finishability to be able to pour it and finish it. So that excess water has to come out. Some of it bleeds out, what we call bleeds out. It'll rise to the top and go out. The dirt will suck it out. Then part of it is dissipated out from the heat as well, and then it shrinks. So when concrete shrinks, it has to crack.
What is the total overall composition of the concrete? I know you got some aggregates, some sand, some water.
Yeah, generally we have, weight-wise, we'll run 1,650 to 1,850 pounds of stone per yard. Generally somewhere average 11 to 1,400 pounds of sand. We'll be around 550, 600 pounds of cementitious material, meaning Portland cement, fly ash, slag, whatever the application is. Then we'll have around 34, 35 gallons of water, and then chemical admixtures.
Now with the chemical admixtures, well, talking specifically about the fiber material that we add to prevent cracking, what is that?
It's a polypropylene, so it's basically a plastic. So it's extruded real fine. What we use, and I have an example I'll show you in a minute, is a microfiber. So what it does is it's a lot thinner, but it's got a real high tensile strength, and it also gives you a lot more fibers. It produces 50,000 or 50 million fibers per pound versus a regular fiber that you see that looks real hairy, generally about 2.5 million a pound. So, you know, you're getting 20 times the amount of fibers in it. So the more fibers, the more micro cracking you can stop.